avoided, right? So avoid creating APIs that simply mirror out the internal structure of the database. Right? The way you have organized your entities, you can't be creating APIs that simply mirror that internal structure. So model the entities and operation that an application can perform on these entities, and then internal implementation should not get exposed.
Hello and welcome to the GeekNarrator podcast. This is your host Kaivalya Apte, and in this series I am talking to leaders and experts in our industry to get key insights from their experience so we can all learn together. In this episode we are going to talk about another very interesting topic, and it's a very common topic that we deal with every day. So no matter what application you are using, what you are doing on the internet, you are some way consuming APIs. So yes, today's topic is APIs and all around APIs. So for example, if you're watching this video, you are consuming APIs or like YouTube APIs or wherever you're watching it. If you're online ordering food online, then you're consuming APIs. So I think APIs is for everyone. It's not just for developers, and it's not just about having an endpoint like on HTTP, but it's way more than that. So when you have to create like a production level API that can be consumed by millions of users across the world, and you want to make money out of it, it needs to be well designed. And there are so many best practices and industry experience that is there. So I'm trying to bring that experience to you. And this episode will try to do that. To do that and to add a lot more value to this session, I have with me Principal Architect at iCertis, Mr. Deepak Patil. So welcome Deepak, and let's start with a bit of introduction, like how you got into APIs and your engineering and like your experience in this industry.
Hey, thank you, Kevin. Nice to be here. So I've been involved in this industry close to 22 years now, where I've been developing mission critical applications, and recently I've been working on developing platform for contract lifecycle management, where anything that you do with two parties, right, it's a binding contract. You buy a phone, you rent a house, it's a contract, right? And to deal with such contracts at enterprise level, we consume API, right? And previously I've been involved with developing supply chain platforms, where a lot of integration happens with third-party systems, which I'll be talking about later. So obviously that's where my primary interest is, developing mission critical systems and using distributed architectures and cloud native systems to develop such platforms and products.
Awesome. So so I'm really looking forward to our discussion. So before we start, let's talk a little bit about the agenda, like what we are going to cover. So it's easy to navigate. So we are going to talk about the what, why, and how of API, like what are APIs, why do we need APIs, and how to go about like designing or creating an API. And then once we form the basis, the foundation, we'll move to a more practical approach, like how do we go about designing an API and what are the key criteria to think about while designing an API. And then we are going to add like a lot of more like live examples, so it's more relevant, it's more like consumable. And let's start with the basic. What is an API? So if we have to define API in a sort of like non-bookish language, let's say, which is easy to understand to any layman. So what is an API?
So I would call it as a software intermediary, right, that allows these two applications to talk to each other, right? So the way we are talking now, actually we are following a philosophy of APIs where we follow a notion that you talk, then I talk, you request, I respond, and so on, right? So in terms of layman's language, obviously application programming interface, it's an intermediary where these two applications will talk to each other. So, example, obviously you send a message on Facebook or you check weather, as you said earlier, on your phone, right? You are using an API.
Yeah, makes sense.
when you use an application on your phone, the application connects to internet and sends the data to server. Obviously, server retrieves the data, it interprets it, and then performs necessary action, right? So that you get the responses back onto your phone, right?
Yeah.
So the application that interprets and represents the data or information to you the way you want it is nothing but an API. I mean, if I go more in details.
Yeah, that makes sense. That is a very simple thing to understand, because as I said earlier, like all of us daily are using like 10 different types of API. Absolutely. Because we are talking on WhatsApp, we are talking to people on Zoom, we are ordering food online, we are booking a cab, we are booking hotels. So there are so many things that we do, and for all this we need APIs, right? So this is all like the contract, like how you talk to any external software. So I think it's a little bit more clear, like why do we need APIs? Because we have to order food, we have to book hotels and all that. But why do we need APIs? Or let's say, why do we need a well-designed API?
So before going to that, right, I would just want to emphasize one more thing, right? So obviously when we use API, right, you have been talking about ordering food, right?
Yeah.
The typical is you go to a restaurant and then you have a waiter who is sitting there by, you order to him and he sends the order back to kitchen, right?
Yeah.
So in this process, similar to what we do when we call API over the phone, your phone's data is never exposed or fully exposed to the server. So this layer of security is also provided by APIs to you, right?
Yeah.
And likewise, your server doesn't expose anything to your data, and then they communicate to each other through small packets, right?
Yeah.
And that's where APIs has become more valuable, where you are exposing a minimal set of functions, what you need, so that API economy can thrive, right? And when you and that brings to the topic, why do we want to implement API, right?
Yeah.
So obviously this question is interpreted in different ways. So first I would like to focus on what is the value of the API, right? It is helpful to think of the value of the effect of API, right? What is the effect of my API when I bring it to the table, and what value it brings, right?
Yeah.
So organization's core business, that's valuable, not necessarily the API, right?
Yeah.
So obviously API is valuable when it becomes a channel. The channel will provide you new types of access to the existing value that organization delivers, right? And that's bring that value of an API, right? Now, another common misconception that happens in this entire process is APIs that are valuable to users should be prepared to pay for it, right? And that's true only in case API itself is a product. But if you look at most of the models that are running today, right, that is not the case. Be it Weather API or be it YouTube API, sometimes YouTube charges it, but API are usually driving some other metrics that you need to focus on, whether it is sales or affiliate referrals or brand awareness. And the value of API to users is the result of API call, which is service request and response, rather than the call itself. So if you get to this, if you understand this, you will know why do we want to implement the APIs, right? Just to drive the most common business drivers.
Absolutely. Yeah. So I think you covered a very important points, and it's so important to understand because most of the times while designing the APIs, we just focus on, the implementation details and not the effect of it. Like, who is the consumer? How are they going to be charged? Or how is this data, whatever we are generating, is going to be used? So all this is so important, even for like developers who don't really focus on the business aspects, but they need to focus to design a well designed API. So that makes a lot of sense. So to give an example, as you said, that the weather API, so you might not be paying for a weather API unless you have some subscription where you get some premium membership or something. That looks weird, but yeah, you can do it. And YouTube charges, so there is a free part, or let's say WhatsApp is one of the biggest examples. So you send hundreds of messages daily, good morning messages to your family daily for free, spam other people. But so basically you are the product, because they are not charging you for sending a message, but they are collecting a lot of information and, they are doing all this processing. So the value or the effect of the WhatsApp API usage is completely different from like directly looking at money. So yeah, that makes a lot of sense. So with that, so let's see, like if I have to like design, so I'm working at an organization and I want to design or create an API. So how do I go about it? Like what does the process look like?
Okay, so while you go for that, right, the second question, right, I mean, when you talked about why do we implement API, and when you go to the organization level and start thinking about designing API, the second question comes into play, right? What concrete outcomes do you want to achieve with this API? What is the outcome that you want to do, right? In other words, what do the API actually do? And what impact do they have on the other wider business strategy that your organization has, right? And so there comes internal view and external view of the organization, right? Because internal view would refer to specific valuable assets. For example, ERP systems, CRM systems within your organization. And then more valuable and unique the services and resources offered, the more suitable they are for API program, right? And that's where you start thinking whether I should be exposing APIs for such assets, right? Now, organizations will also have unique data, right? So that they want to take advantage of that resource by allowing access to that data through the API, right? So unique content, data, and services can make the API extremely valuable. And that's where you need to think that using these APIs, whether I am delivering an asset which is more valuable. So in concrete terms, while the why is unlikely to change that we talked about earlier, the what may significantly based on external factors also, right? Because market, technical consideration, economic conditions. So internal directions about the value of an asset may change. But the effect also should be achieved through the API, right? And that's where identify the outcomes that we want to achieve first, and then you go for design and development of these APIs. And that's where it comes to the third point, which you really ask for, right? How do we plan to execute the API, right? It's not about designing the API. How do we plan to execute? So what technology is used to build this API, how these APIs are designed, how they are maintained, how they are promoted inside, outside of the organization, what resources are available, and how do we measure the outcomes that we have been talking about, right? Right? And that becomes the what part of it.
That makes a lot of sense. So I think it's also about like understanding the big picture and not just. So I want to repeat this because it's so important that, like, especially for developers. So when I'm developing an API, let's say I'm working in a very isolated environment, that I have a ticket. Oh, I need to expose this data and I need an API for that. So I just do that, like just implement it, like go ahead and implement it without thinking a lot of other parts. Like what can be the impact on, let's say, my service, my organization, and of course to the customer. So I think keeping that in mind and like going from outside to inwards and then focusing on the implementation, I think it has helped me a lot, and also like in designing good APIs. So that makes a lot of sense. So I think now that we are clear, about the basics, like what is an API, why do we need an API, and how does the execution looks like? It's not only implementation, but there's a lot more to it. At the organization level, and how do you deliver value to the customer, and how do you bring that value back to the company? So I think that's most important. But let's dive into more practical parts. Like if we have to design an API, what are the other things that I need to take care of? So if I think of an API, so there is, of course, as a developer, I think about technology. So what kind of technology choices I have, what data I expose. So there is also security, and then performance. Of course, it's very dear to me that, it should be performant. It should not be that once I hit an API, it takes like 10 seconds to load a simple thing. So there are so many functional and non-functional requirements that we are going to talk about in this next section. So let's dive right into it. So before that, I keep saying well-designed API. So we need to define what is a well-designed API, right? And So there needs to be some characteristic of a good API. So what are those characteristics?
So the primary goal of an API, if you look at it, right, is to solve some problem the user has.
Yeah.
Right? And then the secondary, but still important goal is to do so with as little effort that is required from the user as possible. Right? So third, API should not create new problems for your users again, right? And typically when we start to do that, I mean, everybody wants that my design should be an architectural milestone. We start creating more problems. So if you have to sum up this in one sentence, what I would say is, we should have we should adopt the functional software elegance when we design and develop this API.
Yeah.
Solve my problem with minimal effort from me and don't get into my way, right? And if you do that, obviously that becomes the APIs which are easy to learn, use, even without documentation, right?
Yeah.
How many times when you have bought a TV or refrigerator, have you read the manual? No, right? Nowadays, we don't look at manuals. So how they are easy to use without documentation, but hard to misuse and appropriate to the audience, right? And that's where some of the characteristics of the good API are coming into play. Obviously, simplicity is one of the one, right? First and foremost, programmers like us tend to solve the complex problem, making it easy to let that complexity bleed through the users of our API. Keeping them simple requires work and obviously presents a serious challenge when we talk about that, right? So there are many ways or different ways to do something. Maybe I want to pass these dependencies through a constructor, or should I do it through setters? We should make it both available, right? So obviously the road to complexity can pay good intention. So fight the urge to add undue complexity. That is what I would say. So good APIs should offer simplicity, and it takes good bit of effort to preserve that simplicity, right? And that's what we need to think, right? The second important characteristics when we are designing is obviously it should provide useful abstractions, right? We have all throughout we have been talking about OOPs and concept of abstractions, but we need to successfully hide details from users of your API, right? Leaving only the essential you offer them through the abstraction, right? So obviously, if you look at today, right, device driver abstract the details of dealing with our hardwares, right? I mean, our hardwares across runs. So 3D models provide an abstraction for worrying about scheduling at OS level, right?
Yeah.
Similarly, well-written API code will provide abstractions, right? You would hide the details, what you need from the users, and if users needs to dive into your code or execution to understand, it means that you have provided a poor set of abstraction, right? And that's where the second characteristics is more important.
Yeah.
And while doing so, third thing is it should be a discoverable API, right? This has to do with how easily a novice can become productive using your code, right? So obviously, as a helpful parallel, I would invoke a no-code example in this case, right? Think of what made our original iPhone that was revolutionary from UX perspective, right? It had a single and a single button, I would say, a screen. So its app left things hanging out on the offside of the screen and practically beg you to discover that, hey, you can do something by swiping left and right? So unlike previous devices where you have too many buttons, these discoverable devices let you, even least savvy users, get onto this usage very quietly and frequently, right?
Yeah.
So you should strive for this in your APIs as well as, right? So obviously users will try to hack and experiment before they call your API, but that's where you need to plan and design accordingly, right? Example, obviously, get last name for the order, right? Or should I give only order and give all the details, right? So these are two different things. So depending on the usage and what users are asking for, you need to design those APIs. And that's where you need to follow the principle of least surprises, right? Obviously, systems should behave in a manner consistent with users of that component are likely to expect, right? Obviously, to put it more bluntly, don't write APIs that would flabbergast your users, right? They don't want to get confused, and that is what I would say. So that's where my experience most of the have been in when we develop APIs is regarding the symmetry, right? So that symmetry could also be said to violate these principles. For example, you are writing an API which would allow you to do system IO functions. A simple case, right? Where you would open a file and you pass a file name as a parameter.
Yeah.
Then it asks you to close the files, obviously. But if you do that without a parameter by taking a reference of that state of that opening file, which means you are actually leaving the user's flagger-busted, right? How do I close a file without having reference to the earlier way, right?
Yeah.
And whenever you call a close method, let's say now you want to send an email to your admin, right? For some reason. Now you will have that astonishment factor. How do I send an email then in that case, right? So a good API do not have properties that cause their users to explain, but that makes no sense. Or how would I even know that, right? That's philosophy in terms of good API has to be removed, right? And that's where you need to consider these 3 different characteristics while designing the good APIs.
Awesome. Yeah, I mean, the way the simplistic manner that you have explained things, it tells about your experience in, designing good APIs, and also looking at some bad APIs and thinking about, why are these designed like this? So just to summarize what you said, because those are really important points, I think you started off with the simplicity, right? The ease of use. So as a customer, I don't need any friction to use an API, because there are so many options available that I can just switch instead of spending time on your API. So it has to be simple to use. And the other important part, different way of looking at it, it should be difficult to misuse, or let's say impossible to misuse. So for example, you're using again WhatsApp API. So it's so easy. Just if you know typing or how to type a message, you can send a message, right? It's so easy. You don't need any other extra details. And it's so difficult to misuse it in a way that if you're sending a message and by mistake you send something else, or like an image or video or message to someone else or to a group. So it's difficult, right? It needs hard effort to do that kind of mistake. So I think ease of use and difficulty in misusing is really important points that we need to think. The second point you mentioned was about abstraction, which means hiding the details that you don't want to expose. So in general, a simple way of looking at it, or rather simplistic way of looking at an API is that, I need to expose something. But I think it's more about hiding a lot of other things that you don't want to expose, right? Yeah. So that is another important point that you mentioned. I think it adds a lot of value. And I think the third one was discoverability, how do customers discover about your API, and then how do they just start using it and without any surprise. So that is really important.
Yeah. And when we talk about the earlier point, right, where I would keep it abstraction as a major consideration, many times we tend to expose whatever that I have to the rest of the world, right? Yeah. And that increases more problem, because then you have to look at what data goes through your network, right? So network latency come into play. If I'm sending too much of data, then I have to bear the ingest, egress cost as well. And then I have to think about compression and security and whether I'm exposing something that it should not be exposed and all that stuff. Right? So as a developer, first thing is start with simplicity and abstraction, right? Yeah. If you get that fixed, then the rest of the things are pretty straightforward.
Absolutely. Yeah. So can we then say that, so when I'm starting on working an API, or let's say designing an API, is it better to be restrictive in terms of what I'm exposing, and then when something is really needed by a customer for a use case, only then expose something? So only expose the minimal things that you have and not everything that you have.
Right. Don't expose more than necessary, right? And if If your business requirements evolve, obviously you start exposing, and that's where we'll be talking later. Is obviously the versioning would come into play, right?
Yeah.
And there are many ways you can handle it. For example, I've been working on developing a supply chain platform where in today's date, right? I mean, if X manufacturer delivers a phone, right? Y manufacturers again immediately want similar type of phone to be in market very next day, right? And when you try to do that, right, to manufacture a phone, you get a lot of components from various places, right? And then you have to ensure that your supply chain efficiencies are made so that these components are delivered at right place at right time, right? Now, consider a scenario that you have some components coming from China region because majority of the manufacturing happens there, and there are certain geographical risks that are happening. For example, there are floods from the plants where your components are coming, or earthquake has happened, or something like that, right? So you need an API where you would get a geographical risk at real time. Geographical risk can be an unrest, which is happening, political unrest or local unrest or some floods, as I said, and so on. So somewhere you will have to aggregate this data. So if you look at AccuWeather APIs, right? I mean, the philosophy that AccuWeather does is for every customer, they customize the API because they don't want to expose something that is more than what that customer needs, right? And that's where, if you want news data for unrest, you want weather data for unrest, you would get that, right? Some might need more. So start thinking about what you are exposing based on your requirement and increase the or enhance the capabilities when you get more use cases on the plate.
Yeah, that was a good example, and I agree to what you said. With this, I'm curious to know. So this the first thing, like we know now that what is a good API and what are the characteristic or best practices that I should follow. The next thing is, what are the different design aspects like of thinking about an API? So as you briefly mentioned before, that there can be like a get order API, or there can be like orders and then you provide like an order ID, and then so this is like two different styles that I see from what you mentioned. So what are these design aspects?
Yeah, so when we talk about design aspects, right, there are 7 primary things, right? Obviously, the orientation of the API, the fluidity, mechanism, the purpose, mutation aspects, structure, and versioning at the last, right? So these 7 aspects would drive the design for your APIs in terms of how we are going to go from business case till end-to-end deployment and measuring and monitoring of the APIs. So if you look at the first aspect, right, orientation, right? So the dominant model for API, if you look at distributed computing for decades, has been remote procedure calls, right? We all know from Java days of Coarse till what we are achieving today with gRPC, right? This isn't surprising. So actually, if you look at it from the way they did it at Fortran, right, or functions or procedures where the primary organizing construct, programmers started to use them to write the code, right?
Yeah.
Now, most distributed APIs are defined obviously by the programmers, and the simplest way for them to think about this distributed API is that allows some procedures of their program to be invoked outside of the program, right? Yeah. So systems like the Coarse provided softwares and tools to help implement these RPCs. While when the people started implementing API on the web, right, obviously you got carried over with RPC concept. And that's where initially WSDL came into play, right? Yeah. So obviously WS standards, which were heavyweights and complex in the nature, right? So that's where we moved on from this heavyweight and complex to HTTP, which is more lightweight. And often we end up calling, hey, I'm writing RESTful, right? Obviously that retains the concept from RPC model. Well, native concepts of HTTP are brought into this, right? Yeah. So there are 2 dominant styles when we talk about orientation in terms of API design, right? One is entity-oriented APIs, right? So where you have an entity and you operate on it. For example, you have the order and you want to operate on order. So you want to do CRUD operations like create, update, delete order, get status of the order, right? These are entity-oriented. Then you have procedure or behavior oriented. So my code will call your procedure, function, and method. For example, get order.
Yeah.
Or provide me the order summary. So these are all behavior oriented. So in case of entity oriented, you put the entity first and then identify the standardized behavior for that entity. Whereas in case of procedure or behavior oriented, you put the behavior first and then the entity.
Yeah.
Right. So when you are designing the API, right, you need to think about whether I should go in terms of entity oriented behavior or behavior oriented behavior, right? So can I model this object or whatever the functionality that I am delivering as an entity? And then can behavior also be standardized, right? So identify the usage first, and based on that, you need to define the dominant style, right? If you can go for entity, that's the best place to start with. Otherwise, go for behavior, right? As I said earlier, right? Create order can have different flavors or similarity, like create order, preview order, and so on, right? Whereas if you look at notification messages, right, send and receive notification message, it is more of a behavioral thing, right? So identify your use case and arrive your dominant style for that API, right? Whether it is entity oriented or procedure oriented API. That gives the flavor of orientation when we start designing the APIs.
Yeah, that makes sense. Just one question here. So looks like as what you explained. So there is this entity orientation and then the behavior orientation, but there's no like one right way. As in, it depends. Like if you want to go for entity orientation, that is like a standard these days. Like a lot of APIs are entity oriented. So you just like say orders API, and then you pass in like order ID, and then you let's say get HTTP get. So you get an API, but you can also go with get by order or get by order ID. So I think it depends on the use case rather than like saying this is the standard and you should do like this. So it does not work like that. It needs to be depending on your use case and what works best for your customer, right?
Absolutely. And many times you go hybrid as well, right?
Yeah.
I mean, you tend to use both styles depending on the use case.
Yeah, makes sense.
And that brings to, I mean, when you are trying to use both, right, that's where fluidity comes into picture, right? What is the spectrum of my API?
Yeah.
Whether I'm doing specific, which is fine grain, to generic, which is coarse grain, right? I mean, so usually granularity in our world is like the level of detailed information available within our API, right? So if you look at your bedsheet thread count, right, in case of coarse-grained API, your data is typically housed in a few large compartments or components, right? While fine-grained API spreads across large number of smaller components, right? So you will have to define that, right? For example, when you talk about orders onto an e-commerce site, get electronic component order, get pantry orders, or get clothing orders. You can have different, which is at this side of grain, whereas get orders where you pass a commodity type, right? Or you can have only a e-commerce API and you just pass order. Order can be of anything, right?
Yeah.
So a fine-grained API promotes less destructive changes, and it will boost your performance and scalability. Obviously, innovation would be faster in case of fine-grained APIs. On the flip side, if you design for coarse-grain approach, it will help you to save your resources. The management of such APIs would be easier, but it will prevent latency and avoid data inconsistency, right? So which approach should be better for you? So you need to think about different aspects, right? So if you look at reusability, right? Today, obviously, when we are writing APIs and when we are doing composite APIs, where one API, when you create a let's say account, you want to also create contacts within that account, right?
Yeah.
So you would have one API to create account, you would have one API to create contacts, but then you are doing composite API, right? And you are reusing something. So fine-grained APIs will have edge here, right? Since more of the information is spread across large number of APIs, they typically offer greater reusability than coarse-grained counterparts, right? So obviously, when you want to use something like that, reusability, fine-grained APIs would be a better choice. But look at scalability now, right? So scalability, again, these APIs should be designed for scale and improve performance. So obviously will go with fine-grained ones because they are doing the point function in that case, right?
Yeah.
But then it can increase your cloud of worker resources, right, at the expense of your enterprise. So
Yeah.
that's a caveat that I would like to say. And obviously, when you look at security and analytics, 3 in a row, you would have fine-grained enables you more security at granular level than coarse-grained APIs, right? But management overhead in terms of coarse-grained APIs is much less, right? That's where we recommend coarse-grained API when we want to limit the management overhead, right? So you need to consider all these things, and the more important one in today's age, even though we have higher bandwidths available, higher storage available, higher computing power available, is latency, right? So fine-grained approach will add more cumulative latency, which is critical for today's mobile application, right?
Yeah.
And in addition, you may have to consider caching solution to mitigate this issue in that case, right? So fine-grained approach features a greater responsibility of addressing the potential failure of each API call, but with coarse-grained approach, there is a chance of single point failure that will happen, right? So you need to consider all these three, or you referred about non-functional requirement earlier, right? So consider these when going for a approach and fluidity of the APIs.
Yeah, absolutely.
Typically, more you would go with a fine-grained approach than a coarse-grained approach.
Yeah, that makes sense. Just to summarize, because you covered like many important aspects to ultimately make a decision what you want to do. Like you go with fine grain or a coarse grain. So of course, if you have like coarse grained APIs, you will have less APIs to manage, and it definitely is easier because you have less APIs. And then having fine grain, you have more number of APIs, but at the same time, you have like very specific APIs. So in terms of, managing those APIs or actually implementing those APIs, it becomes easier because you don't have to worry about a lot of other things that, for example, get by order, right? You don't need to worry about, let's say, mutation. This cannot mutate data. You're just getting an order ID. But if you have like an orders and then you pass one or some order ID, you also have to think about like, what am I doing with this? Like, it's a post, it's a put, or it's a get. So it's slightly different. So I think it boils down to, again, like trade-offs, as everything in software engineering, that it's a trade-off. So if you need more management effort, if you're okay with it, go with the fine-grained ones. If you're not okay with it and you just want like coarse-grained APIs because most of the customers are going to use it for multiple purposes, then go for coarse-grained APIs. And then the other parts that you mentioned were also the non-functional requirements, right? Because they're also very important. That if you need consistency, if you have like 10 different endpoints for kind of updating or doing the CRUD operation on the same resource, it might be a little difficult to maintain consistency because they might be in different databases or whatever. It depends on the implementation, but I think that also drives your decision in going for an entity-based versus behavior-based. So again, it depends on the use case. It depends on what problems you're trying to solve, and it depends on the resources that are available to you. And as you mentioned, another important point was the hybrid model, where you don't have to select one, right? Because you're free to do what you want. So you can decide, like design APIs that are both ways, like entity based, some of the APIs, and then very fine grained APIs for the behavior based. So that makes sense.
Yeah. One more thing is, when you start doing this, right, the complexity also comes into play, right? So with a fine-grained approach, complexity at your node level is very simple, right? But at an entire application network level, the complexity is much higher.
Yeah.
And that's where ability to deploy in terms of coarse-grained API is more destructive in that case, right? Because it is more difficult to move changes and advance to new functionalities toward production.
Yeah.
So if you are into a business model where frequently you are exposing certain functionalities and then you want to give something new on, let's say, bi-weekly basis, depending on your release strategies, right? I would say fine-grained approach would be where you would be driving more towards than the coarse-grained one.
Yeah, that makes sense. And also to look at from the client's perspective or the user's perspective, like if they ultimately just want to do get by order, so they just have one API. So fine-grained API would simply work for them. They don't have to worry about anything else. But let's say if a customer ends up doing all those operations with your 10 different fine-grained APIs, then probably you want a coarse-grained API where you just expose one API, and then based on the other constructs that you provide, they can do like different types of operations. So it's also from the customer's side that there is a little trade-off between management of APIs and ease of use. So yeah.
Yeah, and these things come into play more when you go for transactions which are workflow oriented, right? So when workflows are involved, then you want everything to be packed into one, because you get the entire state available at any point of time. Then doing a point function like getting a report or getting a status or doing certain CRUD operations.
Yeah, that makes sense. So in a way, if I have to compare this with a kind of like a micro API versus a big API approach. You can have like micro APIs when you, let's say, just want to get started. You're not sure what you want to do, what your customers might want to do. But let's say you just want to expose like one piece of data. So let's go with like fine-grained approach. And then, of course, you can have like a hybrid model later on. So yeah, I think it makes a lot of sense. So with this, let's move on to the next part. So I think we talked about the fluidity, like the spectrum, but the purpose of API, as you mentioned.
Yeah. So the purpose, right? Identify who is your consumer and customer, right? So the customer can be an end user, developer, or integrator, right? Yeah. And identify how the functionalities will be used, whether it is between two services, two devices, two applications, and so on, right? Because these services and the way they are used makes a lot of impact on how you are designing. Yeah. Because when you are talking about designing an APIs for devices like IoT devices, right, where they would pass lightweight messaging, right, your construct to design these APIs will also change. So identify the access patterns also when you are identifying the purpose for it, right? Yeah. How the API will be invoked, what they should provide. Is it a pointed query? Or you get all, for example, get device data and get all device data in an IoT platform would be a different ballgame altogether, right? So latency, pagination aspects come into play when you start thinking about this. So purpose is more important. Are you developing API for an end user or for an integrator, which is like combining these two systems, or for your end developer community only, and then how they are going to use it, right? That would define your strategies for mechanism of the APIs, which we are going to talk later, right? Because these all will define how we are going to consume and produce the APIs. Yeah,
that makes sense. So yeah, I think you mentioned a very important point for like, of course, starting with the customer, like how they are going to use your API, what is the domain? Because as you said, for IoT, you want to, have like small pieces of data passing. So it depends on that, like what kind of technology choices you want to make, and all those things will change when your customer base is changing, right? And then I think it's also okay if you have like different set of customer bases, then you might want to choose like different technologies for solving these specific use cases as well. So there is no one size fits all or something. It needs to be focused on the use case, on the customers. And I think starting like before we even start designing an API, this should all be clear. Otherwise, it can make a lot of pain for your customers and yourself, of course, right?
Yes, those designs cannot be corrected later on.
Exactly. And then another point that you mentioned was the access pattern. So it's like a point lookup, just get order by ID or get message by ID or something, or it's like get all messages for a given customer or get all orders for a given customer. And then you also mentioned the pagination, right? And it's so important. So if a customer has, let's say, 100,000 messages sent over an year, You don't want to expose an API, get all messages, and there's no pagination, because ultimately it's going to impact your backend infrastructure, and it might not perform well if you want to just send all those 100,000 messages. So, and the customers may not need that, all those messages together, right? They also are consuming those messages. So in a way, you have to think about like the entire pipeline of the consumption of API and then how it is used. So for pagination, what I have seen is, so it's more like if I have to make it very simple, it's more like providing an iterator to a client. So you just keep on pressing next, and it will give you like the next batch of pagination. And so that works amazingly well. So the customer knows, right? So this is like the partial data. And to get the next batch of data, I want to do this. So how do we usually expose that information? Like, so how do we paginate?
I would add more complexities into it, right? With pagination comes sorting and filtering as well, right? Because that brings more things. Because
Absolutely.
I'm at page 3, and then while I'm iterating, I just want this data to be sorted again. So should I again repaginate, and then I pass additional set of filters to it, right?
Yeah.
So there are ways and means to do that. Usually, if you look at OData standards, right, typically most of these are getting followed through OData.
Yeah.
They provide a set of mechanisms. How do you do, or how do you pass your sorts or filters via headers, but at the same time, as you mentioned earlier, right, you get a iterator, or you get a next call URL as well sometimes, right? But depending on the type of resources that you are using and types of endpoints, because if you are collecting data from 3 different systems to provide this API, obviously I would not only give a iterator, right? I would rather give an endpoint, so that way that endpoint again collects the data given the parameters that are received through your body as well as query string. We'll talk about that, and then gives it, right? So not only pagination, but sorting and filtering, these go hand in hand. And that's where you need to also think about your caching strategy for these API responses, right? You can't cache sometimes the data because it's more fluid, right? Because your sort mechanism changes, your filters changes at runtime. You can't control that. So your caching strategy in terms of in-memory cache or low-memory cache, right? You need to think about those, whether I'm going to cache based on the whole data set for that particular iteration, and then within that cache I'm going to sort or filter, or I'm going to sort and filter from the source itself, right? So depending on the nature of requirements, you do that. Typically when you invoke from ERP systems, right, I would not put my ERP on a much larger load if I have to do all this, right? I would rather cache that data and then give it through ERP, because my ERP's function, typically ERP functions are more transaction oriented, and they need to be performant at their financial or whatever the transaction than this pooling of the data, which are for reporting needs.
Yeah, makes sense. Yeah, so sorting and filtering is of course a lot more difficult. I've seen, like, we just provided like a sort API, and then for a huge customer which has like millions of data points, and sorting all those in one go was kind of impossible, and we were not able to scale. So we had to, limit the based on the time range, and so there is a lot of complexity that you might want to think before exposing like an API with pagination, like a bulk API where you just get everything, because if once you expose something to the customers based on how they are using it, they might come up with new use cases like, oh, I need sorting across, I don't know, 6 months or something, and that might impact the way you like perform in terms of API, right? So it's very important.
Because in pagination you have implied ordering as well, right? So obviously you need to do offset pagination, which is the simplest form, right? Where you give limits and offset, right? But then benefits of that would be easier to implement, and you have a stateless server on which you are doing this, right? Because then you don't have to work regardless of custom sort by parameters. However, obviously they are non-performant for large offset values, right? And when new atoms are inserted into your underlying table, they are not consistent because then obviously your offset changes.
Yeah.
And that's where you go with key set pagination as well, right? Where you use filter for values of the last page to fetch the next set of atoms. So there are certain benefits and downsides of that. And then third is obviously the seek pagination. That is where this is more performant in these days, right? Where you are decoupled from the pagination logic to filter logic, right? And you get consistent performance even with larger offset. So I would say, I mean, majority when you're dealing with large data set, I would go for seek pagination than doing key set or for that matter normal offset pagination.
Yeah, that makes sense, and that's really like helpful based on the use case. Like if you have very less amounts of data, for example, customer orders. So the customer is not going to order like 100,000 orders or something, right? It depends on the use case. But for example, messages, like in once you go into IoT business, there are like so many devices sending like hundreds of thousands of messages every day. And for that, it might need like a different approach. So we need to think all this before we even go further. Thank you for watching the part 1 where we have discussed the basics of API design. In the part 2, we are going to discuss more advanced topics. So please go and watch the part 2. Thank you.